design, one wants a structure not only to be strong but stiff, so that deformations cannot occur. Similar to the Eiffel Tower, the paper structure is also bare with only columns. This is to lessen wind resistance to the structure. As a wall would place heavy stress on the tower due to increased wind resistance, the paper tower, like the Eiffel Tower or other tall buildings, is designed to be wide at the base, and as it reaches the top, it becomes more narrow. Because of a triangle's relationship between intersecting angles and length, triangles may be the most reliable shape in structural design. When you change the angle of a triangle, you change its length as well. The triangle is a stable shape that is a great weight bearer because it's widest at its base. The wide base acts as a support for the weight of the entire structure, opposed to designs with consistent width from bottom to top, which is more prone to topple. Thus, having a wider base indicates more stability within the structure.
Theoretically, for paper towers to be stable, it must be built on a strong foundation. The part of our building that's been found below the ground is its substructure, just like can be seen on buildings. It supports the entire paper tower and keeps it standing tall and strong. In this activity, we are challenged to design and construct model towers out of paper. We are given limited supplies including paper and scissors. Such restriction as to how much paper can be used in the structure. We aim to build our tower with enough height and stability, as well as strength to withstand a simulated lateral wind load. On building process, my group was able to build a stable paper tower. It stood as tall tower at an enormous inches. Besides height, our design did well in height and balance because it stood on its own, which indicates it is strong. However, more extra support would allow us to make it even taller and keep it from falling. Overall, the tower did well, but there is always room for improvement.
Our tower, despite of the structural component of the paper and the considerably short length of the masking tape, has been tested and proved to be successful in standing strong and possibly as tall as it could get without compromising its capacity to stand well. Due to this, we could say that our strategy and overall work was a success. But despite of this, we can still say that there is still a chance for further improvements to do. The thicker the paper, the more sturdier the tower could be. So, if perhaps we have access to better quality paper, we can decrease the tower's susceptibility to be swept off easily or to fall, for with a stronger material means a more stronger base.
As a mechanical part, I would like to say that the paper was rolled and glued by the tape to stand firmly. And I tried to blow air from the fan and our project stand firmly. And our paper tower is a positive result.
As a disaster and risk management engineer, the probabilities in this experiment is either the structure will fall or it will stay on its position. There is a 70% probability that this structure will fall down because of the force given by the strong wind, and the remaining percentage, which is 30%, is the probability that this structure will remain standing or stay on its original position. The structure will only stay on its original position if the base of the structure is well built and it can handle the height of the structure.